Welcome to online lecture series for software engineering KCA 601. So, in this lecture we will be discussing about the functional testing, that is also known as the black box testing, and the test suite data preparation. As the name suggests, functional testing, it is going to check the functions of the software. It is also known as the black box. Black box means my software, it is being treated as the black box. That is, we are going to examine the functionality of the software without going to the internal implementation. Testing, it is tester is only aware of what is the software is supposed to do. What is the logic written behind that, he is not aware, means how is not aware to the tester. He is just testing whether it is the test cases output is coming as per discussed as per SRS, yes or no. So, we can also say is at a specification based testing technique, because the test cases output that is being checked as per specification. If it is coming, yes, the tester will write, or if it is not coming, he will write simply no. Why and which approach the software is using internally, he is totally blind for this. Or it is also known as input output driven testing techniques, means as per the input given, the specified output is coming as per expected output, yes or no. So, this is my input domain, and here I am going to check it for various test data, input test data. This is the system that I have developed and it is under testing. So, whether this system under testing is giving the output and this output is matching with the expected output of the SRS, yes or no, that is being checked by the tester, and here I am following the black box testing approach. There are various approaches for doing the black box testing. The three main approaches are: first is the boundary value analysis, the software is being checked at the boundary values. Then two more values are again being added, that is known as the equivalence class partitioning approach, and third method, it is the cause effect graphing technique. We will discuss one by one. So, the steps that are being followed, they are: first one is to identify the test input, that is the first step that I am going to take. Second, I will be computing the expected outputs with the selected input values. What is the expected output? Then I am going to execute the test cases for these outcomes. For this output, the test cases, they are being executed. Now, next task is to compare the actual and computed expected result. Is there any variance or they are coming same? Then, starting from the first approach, that is my boundary value analysis, BVA. It is a technique to refine my equivalence partitioning. It is an approach that checks whether my written software is behaving properly at the boundaries or no. That is, BVA, it focuses on the boundaries of the input space to identify the test cases, means whatever test cases they are being written, I will be giving the input values of the boundaries, and I am going to check the output that is coming correct or no. So, boundary condition means checking the input value just on the boundary, just below the boundary, and just above the boundary. For example, suppose I have taken one variable x and the range of x is 1 to 100. So, this boundary value analysis means check the software on the boundary, means 1 at 100, just below the boundary, that is at 2 and at 99. So, these values they are being checked 1 to 99 and 100. At these input values, what is the expected output of my software? So, is my software working properly at these boundaries or no, that is my boundary value analysis. So, let us define the two variables x1 and x2. This is my x1 variable and this is my x2 variable. x1 variable range is given me a and b. So, x1 ranges a and b, here this is my a and this is my b. I have defined it a and b, and this similar way the values for x2 is given to me c and d. So, I have defined this will be the possible thing. So, x1 it lies between a and b and x2 it ranges between c and d, both value inclusive. So, as per this x1, checking the software at this values, this a plus 1, 50, 99 and 100. This is the boundary value analysis for x1. Then for x2, checking at c plus 1 at 50 means center nominal value, then d minus 1 and at d. This is the boundary for d. So, in this manner we can increase our these were the two variables, we can take more and accordingly we can calculate the boundary of the software. So, next question comes ki why is the need for doing this boundary value analysis? Because when I have said ki my x1 it ranges between a to b, generally the common mistake that happens by the programmer, he forgets to use less than or equal to and he uses less than only. The software is never being checked for the values at a and b. Suppose I have defined 1 to 100. So, I will just check ki whether my software is going to behave from 8, 90, 40 and all random values I will take. I will simply forget to involve the behavior of the software at 1 and at 100. So, that is the need. Then the programmer forgets to use count 0 while using the counter variable. Suppose take the problem of calculating the next date or take the problem of a triangle. Next date, so suppose I have to calculate the next date for a given day. Suppose I have to calculate, I have given 30 June to 2020 and I want to calculate the next date after this date. So, it should come 31 June 2020, that should be wrong, or it should automatically it should go ki it should be 1 July 2020. Or suppose I have given another example 31 August, what should be the next day after this? It should be 32 August 2000. How well it should behave? So, it should be calculated 1999. Suppose I give 31st December 1999, what should be the next day? It should increment this, it should start from January and then it should do the year increment also. So, knowing the behavior of your program in these conditions, that is boundary value analysis is required. It is very useful in case of the future prediction of the test results of the product. Ki what will be the expected output of the test cases as per these boundary conditions of my inputs. Now, consider one example. Consider a program for determination of the nature of roots of a quadratic equation. The input is the triple of positive numbers, that is a, b and c, and the values they may be from the interval 0 to 100, and the program output it can be any of the following things. Either the it will be not a quadratic equation, first case, either it will have the real roots either we will have imaginary roots or we will have the equal roots. Now, the question is, design the boundary value test cases for this question. Now, coming to the solution, the quadratic equation, it can be taken as ax square plus bx plus c is equal to 0. We all know कि we represent the quadratic equation like this. Now, how we calculate the roots? In maths we know we will find out the b square minus 4ac. There will be three possibilities. Either it will be equal to 0, that is equal roots. If it is greater than 0, then we will have the real roots. If it is less than 0, then we will have imaginary roots. And if a is 0, then equation is not a quadratic. So, in this manner we will proceed. Then, how to write the test cases? The test cases, they will be 4n plus 1, n is 3. So, the 4n plus 1, that is 4 cross 3, because there are 3 variables here a, b and c. So, the test cases will be 13. How well I will write these test cases? The next question is, the first test case is, I will be taking my one variable I will vary and keep other two constant. Constant means I will take them at the nominal value. So, a is varied, b and c, they are kept at nominal. This BVA, it actually it works ki I will be changing one variable behavior and other variables they are kept at the nominal value. So, the value of a as per boundary value analysis, because the range of a is 0 to 100. So, the values will be the values of a, where a should be checked when it is 0 to 100, the values will be 0, 1, 50, 99 and 100. So, I have to check the program behavior on these boundaries. So, one variable I have taken 0, 50, 50. So, if a is 0, I know ki equation is not the quadratic, it should come the expected output. If it is 1, 50 and 50, b square minus 4ac gives me ki what should be the kind of root. So, b square minus 4ac, 50 square minus 4 cross 50 cross 1, that is, it gives me the greater than 0 real roots. Here it is a is 0. Then, when all the 3 are 50, I am getting less than 0 imaginary roots. Then, 99, 50, 50, b square minus 4ac, for this it will be less than 0. 100, 50, 50, again it will be the calculation of b square minus 4ac will be less than 0. Then, these 5 cases are being tested. Next thing, change the value of b and keep a and c at their nominals. So, a and c, they are kept at nominals 50 and b is now checked at 0, 1, 50, 99 and 100. Since 50, 50, 50, that will be repeated. So, I have omitted the value of 50, 50, 50. I have taken only 1, 0, 1, 99 and 100. So, the values are now 50, 0 and 50, that is the b square minus 4ac, for this value it will be less than 0. So, that is the imaginary roots. When they are 50, 1 and 50, then again it is less than 0 imaginary roots. 50, 99 and 50, that will be again less than 0 imaginary roots. 50, 150, it is giving us b square minus 4ac is equal to 0 equal roots. Now, keep the a and b at nominals and vary the c variable for boundaries, that is 0, 1, 99 and 100. 50 I am omitting because that has been already incorporated. So, 50, 50 and 0, the value of 4ac, b square minus 4ac, it will be less than 0, that is greater than 0, that is real roots. 50, 50 and 1, again greater than 0, 50, 50 and 99 less than 0, imaginary. 50, 50 and 100, again it will give us the less than 0. So, imaginary root. So, I have calculated the test cases for boundary value analysis for this quadratic equation. 13 test cases are being defined. Then next kind is robustness testing. Robustness, it is the extension of BVA. It says ki when the extreme values they are exceeded with the value slightly greater than the maximum and a value slightly less than the minimum. That is, earlier I was checking 0, 1, 50, 99 and 100. Now I will include slightly less than the minimum and slightly greater than the maximum. That means -1, 0, 1, 50, 99, 100 and 101. So, these 6 cases for any variable, one single variable will be checked. So, 6n plus 1, that will be the test cases when I am doing with the robustness testing. Then another kind of testing means worst case testing. Worst case means seeking the program behavior when more than one variable can change their extreme value, that is known as the worst case. Here I can say कि boundary value analysis is my subset is the worst case test cases. So, if I am going to check the behavior of my program for n variables, it should come 5 raised to power n test cases. Suppose I have checked for quadratic equation in which 3 variables were there. So, it will generate 125 test cases, and as per robustness testing, the roots of quadratic equation, it will generate 19 test cases, and the boundary value analysis we have done for the 13 test cases. Now, which approach to follow? As this checking for 125 test cases, this was just a small program. So, in the real life scenario, we will discuss first the worst case, but checking for worst cases every time is not possible. So, we will be following robustness or we will be following the boundary value analysis, so that the program behavior test cases, as per test cases, they are being properly checked. Then the second kind of approach, that is my equivalence class testing. So, here I will be checking my program as per input domain. So, the domain, what should be the input domain? Domain should be, it is partitioned into the finite number of equivalence classes. As the name suggests, equivalence class partitioning. So, that means I am going to check the behavior of my program as per the input values, and those input values, they are being partitioned into 2 sets, that is finite number of equivalence classes. So, this partitioning, how it is being done? This partitioning, actually it is telling the behavior of the program, and it is done ki every time to which class I can put on my input set of data, that is for every input data belonging to which equivalence class I will be doing the partitioning. So, it is used to reduce the total number of test cases to a finite set of test cases, so that they all can be tested and the maximum requirements they are being covered. 2 steps they are being required to implement this method. First, the equivalence classes, they are being identified by taking each input partition and partition them into the valid and invalid classes. So, once they are being identified and they are being divided into valid and invalid, now the next task is to generate the test cases using this equivalence class identified in our first step. So, this is my input domain, as I said, as per the first step it is being divided into valid inputs and invalid inputs. This is the module that is under test. Now, the outputs are being categorized accordingly. Now, take one question, the same program. Consider the program for the determination of nature of the roots of the quadratic equation, as we have done it earlier previous in the boundary value analysis. Now, we have to identify the equivalence class test cases for the output and input domain. What should be the output domain? Please see. I can say the first output as not a quadratic equation if A is 0. The four possibilities are 1, A is 0. The second possibility 1 B square minus 4 AC is greater than 0, that is the real roots. The third possibility, that is when B square minus 4 AC is less than 0, or the next output that can have B square minus 4 AC is equal to 0, that is the equivalence equal roots. So, the number of test cases that can be derived from these above relations, they can be shown as the first test case I have taken when there is a not a quadratic equation, then real roots, imaginary roots and equal roots. So, the four test cases they are being derived. Then another input domain that can have once first when I says when I have taken A as 0, then the second input that can have A is less than 0. Third is when A is lying between 1 and 100, checking the program behavior. These three values they are taken as per A. Fourth it says A greater than 100. These four values they are as per A. Then 5, 6 and 7 they are for B. B1 it is residing between 1 and 100 when B is less than 0 and 1 B is greater than 100. So, 4 values for A, 3 values for B and then the third variable change when C is residing between 0 and 100, C is residing, C is less than 0 and C is greater than 100. These are the 3. So, total 4 plus 3 plus 3 plus 4, 14 test cases they are being covered using this equivalence class testing. So, we will be dividing these 14 test cases and we will be moving accordingly. So, next technique, third approach, it is our cause effect graphing technique. Cause effect graphing technique, it explores the combinations of various input circumstances. Here in the boundary value and in the equivalence class partitioning, we have taken only one variable change. There can be the case when we have to combine the various inputs. So, in that case these two approaches fails. So, the third approach, that is my cause effect graphing technique, it works to explore for the combination of various inputs. Then it gives a concise representation of the logic condition and their corresponding actions. What are the possible ways of my input and as per combination of those possible ways what output I will be getting. Then third, it tells us where I am getting incomplete and ambiguity in my specification. This method clearly focuses on incompleteness and ambiguities. Here as the name suggests, cause it will be defined as the input and effect it will be the output. So, cause is my distinct input condition of my input conditions and effect it is my output conditions, they are from the output conditions. Then what are the different steps for cause effect graphing techniques? Cause and effects in the specifications, they are identified as the first step is the identification. Then the semantic content of the specification is analyzed and it is transformed into the Boolean graph that as per the input conditions what should be the output. So, the Boolean graph is drawn, we are next coming to that. Third step, once we have drawn this graph, it is converted into the decision. Then in the columns in the decision table, they are being converted into the test cases. So, first step I am identifying the inputs, second step I am making a Boolean graph representing this input and output in the form of cause and effect. After then I am drawing the decision table and from that decision table I am moving on to the test cases. We can see if there is identity, so from C1 to E1 I will moving. If it is not the case, I will do like this. If there is a OR condition, so from any input I can move on to effect output condition. I will represent like this and it is being represented by C1 and C2. If all the conditions they have to be must in my program and then I will be reaching to the effect. Now, next there is one question given to us. The character in the column 1 must be an A or B. The character in the column 2, it must be a digit. In this situation, the file update is made. If the character in the column 1 is incorrect, the message X is issued. If the character in the column 2, it is not a digit, then message Y is issued. These are the statements given to us and draw the cause effect graph for this question. So, from these first we will write the different causes. The causes in this case, the character in column A must be an A. So, first cause we will write C1 ki character in column is A or B, B also can be there. So, C2 I will define another cause, the character in the column 1 is B. Then C3 cause I am making from the second situation, the column 2 must be a digit, that is the character in the column 2 is a digit. So, these three causes they are being defined. Now, the effects are given to us, we will write the effect. E1, first effect, the update is made. The second effect, one error, that is in the column 1 agar incorrect, then message X is issued and the third effect message Y is issued. So, these three effects can be there. So, now the next step is to draw the cause effect. As I say ki C1 or C2 can be there. So, C1 or C2 it is giving me the first intermediate effect, that is EA. Then the second is from this EA and C2 they both should be there. This is my E1. Then if EA is not there, ki either A or B is not there, I will be printing the second message X is issued. So, and if C2 is not happening, so I am going to issue the message Y, that is my E3. So, in this way I have represented my program into statements and then I have drawn the cause effect graph. So, this was all about doing the functional testing. Thank you.